So here we're going to do an example. So a population has a mean of 110 and a standard deviation of 45. That's the population. What we want to do is find the mean and standard deviation for the sampling distributions of the sample means. So what in the world is that, right? So the mean of the sample means is the mean of x bar, all right, which is defined to be mu, and the standard deviation of the sample mean is defined to be sigma divided by the square root of n. Now, the only way that we can use this powerful tool right here is if we know the central limit theorem applies. And do we know that the central limit theorem applies? What do we have to check to be able to use this powerful thing right here? We have to know that n is greater than or equal to 30, or the population is normally distributed. Now, is the population normally distributed? Well, it says a population has a mean of 110 and a standard deviation of 45. It doesn't say anything about the population, so we cannot assume that it's normally distributed. However, what does it say? It says that n is equal to 36. So they go out and they sample 36 people. So that satisfies n greater than or equal to 30. So I can get rid of that question mark. CLT is good to go. So this is what I'm looking for with your work. I want you to say CLT n greater than or equal to 30. Tell me why you can use this amazing formula right here. Look how easy it makes it, guys. Mu is 110. So the mean of the sample mean is equal to 110. Wow, so easy. Standard deviation of x bar. Okay, standard deviation of the sample mean is equal to standard deviation over the square root of n for the population. Standard deviation for the population is 45. Square root of n is 36. So this is equal to 45 divided by 6, and I think that reduces to 7.5. Okay? Now, the question becomes, find the probability that the sample mean is greater than 120. Okay? So find the probability that the sample mean is greater than 120. So let's see if we can do this. All right? So how do we do the sample mean? All right? So if you thought about this, z equals x minus mu over sigma, right? But now, instead of x, we have x bar, right? So we have x bar. What is the mean of the sampling distribution of sample means? That's mu sub x bar. What is the standard deviation? It's the standard deviation sub x bar, right? So what does this equal? Well, with the central limit theorem, the mean is the mean, and the standard deviation is the standard deviation divided by square root of n. So this formula becomes x bar minus the mean over the standard deviation divided by the square root of n. Okay, very powerful formula right here. Okay, so this is our formula that we're going to use to find our probability. So the probability that x bar, the sample mean, is greater than 120. How do we do this? Well, I'm going to subtract the mean. So 120 minus the mean. What was the mean? The mean was 110. The mean of the sample means is 110, and the standard deviation of the sample means is 7.5, right? So it's 110 divided by 7.5. So what is that going to be? That's 10 divided by 7.5, blah, blah, blah. So that's 1.3333, right? But look, you can't put 4 decimals. Remember, your table only goes out 2 decimals for your z-score, right? So this becomes the probability of x bar minus the mean over standard deviation divided by square root of n, which is greater than, and then we got 1.333333, right? And that goes on forever. Now, This right here is replaced with z. So this is probability that z is greater than, well, since I only do 2 decimals, 5 or more raised score 4 or less, let it rest at 1.33, okay? And I go look up this number. Now, there's an issue here. It's greater than. So what does that picture look like? Always draw your picture so you don't mess this up. Zero's in the middle. 1.33 is on the right side of 0. I want z's that are greater than 1.33. So the area in the table is going to be to the left, right? It's cumulative, right? So that number that you look up is going to say 0.9082. Now 0.9082, that's the area to the left, okay? So that area is to the left. Now, how do we get area to the right? We do 1 minus 0.9082. And what do I get? I get 0.0918. So the probability that the mean of the sample means is greater than 120 is about 9%. 9.18% to be exact. Okay? Very, very powerful right there.